All right, welcome back. So we're gonna keep going with the Hugging Face course, and hopefully finish up this unit before the next unit is released tomorrow. So we've got a big uh, section here, multi-agent systems. Multi-agent systems enable specialized agents to collaborate on complex tasks, improving modularity, scalability, and robustness. Instead of relying on a single agent, tasks are distributed among agents with distinct capabilities. In small agents, different agents can be combined to generate Python code, call external tools, perform web searches, and more. By orchestrating these agents, we can create powerful workflows. A typical setup might include a manager agent for task delegation, a code interpreter agent for code execution, a web search agent for information retrieval. The diagram below illustrates a simple multi-agent architecture where a manager agent coordinates a code interpreter tool and a web search agent, which in turn utilizes tools like the DuckDuckGo search tool and Visit Web Page tool to gather relevant information. So here we go, manager agent, code interpreter tool, web search tool, visit web page tool. So multi-agent systems in action. A multi-agent system consists of multiple specialized agents working together under the coordination of an orchestrator agent. This approach enables complex workflows by distributing tasks among agents with distinct roles. For example, a multi-agent RAG system can integrate a web agent for browsing the internet, a retriever agent for fetching information from knowledge bases, an image generation agent for producing visuals. All of these agents operate under an orchestrator that manages task delegation and interaction, solving a complex task with a multi-agent hierarchy. Okay, so this will be in a notebook, so let's get logged in. So I'm going to open this in Collab and install the modules, authorize it, even though it's not a trusted space, trusted notebook. Um, okay, and then I'll be logging into using my credentials, so I'll pause it and do that off camera. But in the meantime, let's continue. The reception is approaching. With your help, Alfred is now nearly finished with the preparations. But now there's a problem. The Batmobile has disappeared. Alfred needs to find a replacement and find it quickly. Fortunately, a few biopics have been done on Bruce Wayne's life, so maybe Alfred could get a car left behind on one of the movie sets and re-engineer it up to modern standards, which certainly would include a full self-driving option. But this could be anywhere in the filming locations around the world, which could be numerous. So Alfred wants your help. Could you build an agent able to solve this task? Okay, so here's the task. Find all Batman filming locations around the world, calculate the time to transfer via boat to there, and represent them on a map with a color varying by boat transfer time. Also represent some supercar factories with the same boat transfer time. Let's build this. This example needs some additional packages, so let's install them first. So pip install, there we go. So I can read it from the notebook or from there. Let me kind of do both. I'll focus on reading on it here because it's formatted a lot easier, and then switch over to run the cells. So I gotta do authentication. I'll do that off camera. I'll be right back. All right, I'm back, and I invalidated and refreshed. So even if I leaked an old a token out there, it's invalidated now. I got the new token in. So let's run this cell here. We first make a tool to get the cargo plane transfer time because we're trying to um, Find all Batman filming locations in the world, calculate the time to transfer via boat to there, and represent them on a map with a color varying by boat transfer time. Also represent some supercar factories with the same boat transfer time. Which, honestly, I gotta say as an aside, that's kind of a scary assignment. Like, AI safety is a really important thing. So, like, this objective, like, you can imagine just how, an objective like this could so easily be unsafe, right? It's like, like, I guess the easiest, yeah, I won't even give an example because I feel like it's so easy to imagine this world where you're one step ahead using AI. It's just kind of concerning. Anyway, let's move on. So let's build this. This example needs some additional packages, so let's install them first. Oh, okay. So next should say. Okay, so we first make a tool to get the cargo plane transfer time. So there we go. Setting up the agent. For the model provider, we use Together AI, one of the new inference providers on the hub. All right, so these are inference providers. An inference provider is I don't know, doesn't say. The Google search tool uses the SERPer API to search the web. So this requires either having set up env variable and passing this, or having SERPer API key and passing provider equals SERPer. If you don't have any SERP API provider set up, you can use DuckDuckGo search tool, but beware this has a rate limit, so it'll happen really slow. I think I do have the key. I remember doing that in another video. Yeah, so I think I can just log in and get my key. I'll do that off camera, so I'm not just showing that key to the world. Um, so, so I would like to use my key. So it explains how to do that. It says to use the Google search tool, um, you have to have a environment variable set up. I believe I do, and I believe it's hidden. So if we go into secrets, yeah, we see I do have that set up. It's not enabled though, so let's turn it on. All right, looks great. Um, and then um, and then you have to pass provider equals rather than together. You can change it to uh, yeah, we can change it to SERPer. But here they're using together, so I don't know. From the model provider, we use Together AI. Okay, regarding the search tool, this requires interesting because we can see they're using together, so like that should be fine, right? I don't know. Let me change it to SERPer. Okay, and we're gonna call it um, we're gonna say provider equals SERPer, which doesn't work because SERPer isn't defined anywhere, so we should get an error here. Yeah, and we can see already it's not defined. So um uh yeah, I'm not sure how this. Yeah, these instructions are very strange. You would pass it probably the name of the key, or unless you named the key that way, but those are very odd instructions. Let's just try to use it let's just try to use it like normal. We're gonna say together instead. Let's see if this works. All right, so that worked just fine. Okay, so we can start by creating a simple agent as a baseline to give us a simple report. All right, so we'll do that. So we're going to define this variable here, which is a string that describes the task. Then we're going to, oops, never. Then we're going to, here we go. So now I do have that key there. We saw that in the variables. So this goes through without an error. And now we can use it to build our code agent. Perfect. And let's run the agent. Grant access to the secret I had. And there we go. Easy. Yeah. All right. So in our case, it generates this output. All right. We could already improve this a bit by throwing in some dedicated planning steps and adding more prompting. Planning steps allow the agent to think ahead and plan its next steps, which can be useful for more complex tasks. All right, so let's give it some planning steps. Boom. So we give it 4 planning intervals, and then we're running it again. So we're doing agent.run and running it again, and we should get a report with more details once it's finished. In our case, it generates this output. Okay, so now we can see, um, interesting. Well, thanks to these quick changes, we obtained a much more concise report by simply providing our agent a detailed prompt and giving it planning capabilities. Interesting. The model's context window is quickly filling up. So if we ask our agent to combine the results of detailed search with another, it will be slower and quickly ramp up tokens and costs. We need to improve the structure of our system, splitting the task between 2 agents. Multi-agent structures allow to separate memories between different subtasks with 2 great benefits. Each agent is more focused on its core task, thus more performant. Separating memories reduces the count of input tokens at each step, thus reducing latency and cost. Let's create a team with a dedicated web search agent managed by another agent. The manager agent should have plotting capabilities to write its final report. So let us give it access to additional imports, including uh, matplotlib and GeoPandas, plus Shapely for spatial plotting. All right, let's do that. Oops, so we got an error here. Perfect. So I'm out of credits. I need to subscribe to Pro Mode for Hugging Face to be able to use their inference provider. So they'd like me to use that because they want me to give them money, but I'm gonna try it with something else. So let's look at the pricing plans that Hugging Face has. So Hugging Face free account. You can host unlimited public models and data sets, create unlimited orgs, access the latest ML tools. Damn good deal. Wow, look at that. Um, but to with Pro mode, you get uh, serverless inference, higher usage limits. We can see that the limits you get with there doesn't even allow me to run this notebook here. All right. Yeah, so we could try it with the other one. I just am not sure how. Um, Oh, you know what? I think I burned them all up on this first one here is why. So I'd probably just burn them up on my other one. All right, that's okay. We can just move on. Yeah, let's just move on. So now this is the detailed report. It's not defined because I ran out of credits to run that. Okay, so thanks to these quick changes, we've changed a much more concise report by simply providing our agent some remember. So I read that. The model's context window is quickly filling up. Read that. So if we ask our agent to combine the results of detailed search with another, it will be slower and quickly ramp up tokens and costs. We need to improve the structure of our system. So that takes us to the next part, splitting the task between two agents. Multi-agent structures allow separate memories between different subtasks with two great benefits. Each agent is more focused on its core task, thus more performant. Separating memories reduces the count of input tokens at each step, thus reducing latency and cost. Let's create a team with a dedicated web search agent managed by another agent. The manager agent should have plotting capabilities to write its final report. So let us give it access to additional imports, including matplotlib and GeoPandas plus Shapely for spatial plotting. All right, so next cell there. Oh, and this is not going to work because uh, well, we can figure out why. So we got an unexpected keyword argument provider here. So it couldn't accept that provider keyword argument, which is interesting. Um, which is really interesting. And my keyboard has stopped working again because it does that sometimes, and it's really disruptive. Okay, well, my keyboard doesn't work. What I can do is copy a quote from here, copy selection, and then paste this in. Oh, I actually can't paste selection, unfortunately. All right, well, my keyboard doesn't work, so I'm not sure what I can do. I guess I can try um, to put this cell somewhere else, and maybe my keyboard works. No, my keyboard just doesn't work at all. Okay, it does work outside of the browser for some reason, so I'll copy paste the cell in there, then add the quotes here where the keyboard does work. It seems like the keyboard stops working because like the application doesn't process the input of the keyboard. But this doesn't work. Yeah, you can't use provider like that. That's not how that works. Yeah, you can pass it to the HFAPI model, but this is not right. Let's try this. Yeah, so this provider is not supported. Well, that's okay. All right, so splitting the task between two agents. Multi-agent structures allow to separate memories between different subtasks with two great benefits. Each agent is more focused on its core task, thus more performant. Separating memories reduces the count of input tokens at each step, thus reducing latency and cost. Let's create a team with a dedicated web search agent managed by another agent. The manager agent should have plotting capabilities to write its final report. So let's give it access to additional imports, including matplotlib and GeoPandas plus Shapely for spatial plotting. So there we go. Okay, try doing that, and it's just I don't have the yeah, it's not going to work. It's the instructions of this are very unclear. They say to set it up for that send poppy or whatever, but it doesn't work. The manager agent will need to do some mental heavy lifting. So we give it the stronger model, DeepSeek-R1, and add a planning interval to the mix. All right, let's try that. Yeah, so this doesn't work. We don't have an open API key. And I'm not going to get one. That's, there probably is some free usage. We could probably swap some of the parameters out and do this example very cheaply, but I just feel like there's no need to do that. So let's inspect what this team looks like. Unfortunately, I cannot. This will generate something like this, helping us understand the structure and relationship between agents and tools used. All right. I don't know how that went in your run. Not well, but in mine, the manager agent skillfully divided tasks between the web agent in one, search for Batman filming locations, then two, find supercar factories before aggregating the lists and plotting the map. That did not work for me because I'm not willing to pay for this example. Let's see what the map looks like by inspecting it directly from the agent state. So manager agent dot Python executor dot state fig. This will output the map. So, wow, that's cool. You get a map. That's cool. So, multi-agent systems. We get a overview of multi-agent systems. What is agentic reg? Introduction to agentic reg. Multi-agent reg system recipe. Step-by-step guide to building a multi-agent reg system. So, I feel like this would be better. Uh, I don't know. Anyway, so almost done with this. This next one is vision agents with small agents. The examples in this section require access to a powerful vision language model. We tested them using the GPT-4 API. However, why use small agents discusses alternative solutions supported by small agents and Hugging Face. If you'd like to explore other options, be sure to check out that section. Yeah, and I would like to use other options. All right, so empowering agents with visual capabilities is crucial for solving tasks that go beyond text processing. Many real-world challenges, such as web browsing or document understanding, require analyzing rich visual context. Fortunately, small agents provides built-in support for vision language models, VLMs, enabling agents to process and interpret images effectively. In this example, imagine Alfred, the butler at Wayne Manor, is tasked with verifying the identities of the guests attending the party. As you can imagine, Alfred may not be familiar with everyone arriving. To help them, we can use an agent that verifies their identity by searching for visual information about their appearance using a VLM. This will allow Alfred to make informed decisions about who can enter. Let's build this example. All right, so providing images at the start of the agent's execution. So this is another Google Colab notebook. Let's see if this works out here. Now, this is another Google Colab notebook that will use resources that I can't use. It did say that you could perhaps swap some of the resources out for small agents. So I will try that. In this approach, images are passed to the agent at the start and stored as task images alongside the task prompt. The agent then processes these images throughout its execution. Consider the case where Alfred wants to verify the identities of the superheroes attending the party. He already has a dataset of images from previous parties with the names of the guests. Given a new visitor's image, the client can compare it with the existing dataset and make a decision about letting them in. In this case, a guest is trying to enter, and Alfred suspects that this visitor might be the Joker impersonating Wonder Woman. Alfred needs to verify their identity to prevent anyone unwanted from entering. Let's build the example. First, the images are loaded. In this case, we use images from Wikipedia to keep the example minimal, but imagine the possible use case. All right, so first I need to log in. Okay, I will do that. I'll do that off camera. All right, and I am logged in. So let's run this next piece, which just simply takes images from Wikipedia. We see the URLs there that it'll take the images from, but we do have this red underline. It looks like image equals, so we cannot identify image file. So something went wrong. Maybe I forgot to run a cell. Maybe I accidentally skipped a cell. Nope, I ran all the cells. So there was cell 1, cell 2, and then this would be cell 3. So that's not what went wrong. So we've got image.open. So this response.context wasn't a um, yeah, so I think what went wrong is this response didn't populate correctly. Yeah, so let's try let's comment these two lines out, and then let's do a troubleshooting of that response. So we'll do response.text. So let's do print, yeah, response.status code. Perfect. Perfect. And run the cell again. Okay, so we can see for this first one, we got a status code of 403. So that's the error we got. For some reason, it wasn't able to pull down this here, even though it was for the second one, which is interesting. Huh. What's a 403 again? It means that the server understands the request but does not allow access. Okay, so it's like not allowing access to this one. Interesting. But it does allow access. It's not allowing like it's not allowing access through the API. Uh, okay. Yeah, like because it's like slash commons or whatever, it's doesn't seem to be allowing access. Um, well, let's go to the AI and see if we can get help with this. Okay, we'll say, why am I getting a 403 trying to access when I can pull it up in the browser? Okay, yeah, that's what I thought. It's blocking the strip. Okay, well, is there one? Can I get one that doesn't the headers? Yeah. Um. All right. Yeah, let's change the headers. Damn it. Let me change the headers. There we go. All right, and then I request dot get headers equals headers. All right, maybe this will work. Yeah, now we got a 200 for both of those. So now we can change the comments and let it fly. There we go. Now that we have the images, the agent will tell us whether the guest is actually a superhero, Wonder Woman, or the villain, Joker. Oh, and I don't have. Okay, so we'd have to kick off the agent to do that, but I don't have an open API. Right, right. So we could use a small agent instead. Yeah. So we can see from small agents open a AI server model GPT-40. We could use a different one because GPT-40 is going to be uh you have to pay. Anyways, I need a break. I'll be right back. All right, I'm back. So where was I? Going through this. Yeah. So in the case of my run, the output is the following, though it could vary in your case, as we've already discussed. In this case, the output reveals that the person is impersonating someone else, so we can prevent the Joker from entering the party. All right. So yeah, I would have to get that to work. Uh, Give it a different model, but I mean we could do it with the yeah. Let's do that because that should be pretty easy to do. So if I duplicate this and then go to my profile, uh, so we got a catering service. Yeah, so we've got the. Let's go to my cleaning agent. Then the files there and app.py. Um, yeah, so HF API model. Okay, so now we can make the model out of this code here, and it should work. Yeah, so instead of model equaling that, it'll equal this. Okay, and then everything else can be the same, so this should work. Grant access. Oh, you know what? We gave it a text. We gave it the wrong kind of model. We have to give it a vision model. So we have to give it a different model ID. So if we go to models, or we can go computer vision, we can say image to text, possibly. So uh, let's try this one. Yeah, we'll do use this model. Okay, should be able to do this. So I can stop this cell because it's correct. Uh, okay, so now I can get rid of all of this. And hopefully this works now that it's the right kind of model. All right, I'll just leave that to run. So coming back, so providing images with dynamic retrieval. The previous approach is valuable and has many potential use cases. However, in situations where the guest is not in the database, we need to explore other ways of identifying them. One possible solution is to dynamically retrieve images and information from external sources, such as browsing the web for details. In this approach, images are dynamically added to the agent's memory during execution. As we know, agents in small agents are based on the multi-step agent class, which is an abstraction of the React framework. This class operates in a structured cycle where various variables and knowledge are logged at different stages. So number one, system prompt step stores your system output. Number two, task step logs the user query and any provided input. Number three, action step. It captures logs from the agent's actions and results. This structured approach allows agents to incorporate visual information dynamically and respond adaptively to evolving tasks. Below is the diagram we've already seen, illustrating the dynamic workflow process and how different steps integrate within the agent lifecycle. When browsing, the agent can take screenshots and save them as observation images in the action step. Okay, so how .run works, and we can make it work with images. So number one, preparation. Put the task and now images into a task step and add it to logs. Number two, while final answer tool has not been called, 2.1 agent.write inner memory from logs parses logs to make a list of LLM agnostic chat messages. 2.2, these chat messages are sent to the model. The model returns a string answer, including a code blob that is extracted. 2.3, the code blob is executed. Any tool calls in it call the specific tools as functions, then continues running the code. So that's generation, parsing, and execution. And then 2.4, all execution logs, including possible errors, are put into an action step that then gets appended to the logs. A callback can take a screenshot and add it to the step under observation images. And 3, when final answer tool has been called, run returns its argument. So its argument can be images as well. So added support for images in all model subclasses goes under model. So let's see how it's going so far. Guessing it's not going good. Oh, look, perfect. So, oh, look. So the output reveals the person is so yeah, it identified it as the Joker because we used that model, that other model that did it instead of paying for it. Isn't that awesome? Cool. So yeah, it's just as easy as going in and looking up other models on Hugging Face. So you just click on the models, and then the models are all hosted and running and free to use for some simple things. You just got to click use this model, and it gives you the code for how to use it. Now there might be some kind of um, some sorts of like limits for how much you can use, but so far so good. Okay, so now that we understand the need, let's build our complete example. In this case, Alfred wants full control over the guest verification process. So browsing for details becomes a viable solution. To complete this example, we need a new set of tools for the agent. Additionally, we'll use Selenium and Helium, which are browser automation tools. This will allow us to build an agent that explores the web, searching for details about a potential guest and retrieving verification information. Let's install the tools needed. So pip install small agents all. Okay, so that would be the next part of the notebook. Oh, you know what? Actually, this is going to be yeah. So this is part of the Python file. Yeah. So pip install small agents all Helium, Selenium, Python. So yeah, here we're importing that. So I could do that on my local. I'm just afraid that it would eat up a lot of space to install all that. So we'll need a set of agent tools specifically designed for browsing, such as search item control F, go back, and close pop-ups. These tools allow the agents to act like a person navigating the web. So let's look at that. So we're going to go to here and we're going to do wasl dash list. So we've got Debian. Yeah, so I'd want to create another Windows subsystem for Linux, probably Ubuntu, on my other drive to do all this on. Um, well, anyway, we also need functionality for saving screenshots, as this will be an essential part of what our VLM agent does to complete this task. To complete that task, this functionality captures the screenshot and saves it in step log observation images, allowing the agent to store and process the images dynamically as it navigates. This function is passed to the agent as step callback, as it's triggered at the end of each step during the agent's execution. This allows the agent to dynamically capture and store screenshots throughout its process. Now we can generate our vision agent for browsing the web, providing it with the tools we created, along with the DuckDuckGo search tool to explore the web. This tool will help the agent retrieve necessary information for verifying guests' identities based on visual cues. With that, Alfred is ready to check the guests' identities and make informed decisions about whether to let them into the party. You can see that we include helium instructions as part of the task. This special prompt is aimed to control the navigation of the client, ensuring that it follows the correct steps while browsing the web. Let's see how this works in the video below. Okay, so this is the final output. Final answer, Wonder Woman is typically depicted wearing, okay, all right. So with all that, we've successfully created our identity verifier for the party. Alfred now has the necessary tools to ensure only the right guests make it through the door. Everything is set to have a good time at Wayne Manor. So further reading, we just gave sight to small agents. Uh, Blog describing the vision agent functionality, which is so cool. You don't have to just make a text agent. You can do anything any of these models can do. Really, really cool. Uh, Web browser automation with agents, example for web browsing using a vision agent. Web browser vision agent example for web browsing using a vision agent. So there we go. I'm going to finish this up. So exam time. Well done working through the material on small agents. You've already achieved a lot. Now it's time to put your knowledge to the test with a quiz. Instructions. The quiz consists of code questions. You will be given instructions to complete the code snippets. Read the instructions carefully and complete the code snippets accordingly. For each question, you will be given the result and some feedback. This quiz is ungraded and uncertified. It's about you understanding the small agents library and knowing whether you should spend more time on the written material. In the coming units, you'll put this knowledge to the test in use cases and projects. Let's get started. So this is one where now it is ungraded and uncertified, but it looks like um, it does require a login to start. So I'm gonna do this off camera just because it's not just out there in the open. It's behind a login screen, and I don't want to just do it uh, violate some sort of expectation. So I'll pause and do it off camera, and then come back with my results. All right, I'm back. So I did get one part of it wrong. I just copied the code over from here. Now this is a modification to the code. Um, Typically, it should just be like that. So I did get something a bit wrong. I'll just show it. It's ungraded. It's not a big deal. So here it is. Here's what I did. So if I try to redo the quiz um, and change that, then I should get full credit. But it's fine. That's enough to move on. It's ungraded and uncertified, so there nobody even sees this. It doesn't count for whether or not I get the certification or anything like that. So I got everything right. I just needed to um, use the model that they were expecting, but at the same time, nowhere in the question did they say the model that they were expecting me to use. They just said me to use a model, but they didn't say which one. So it's kind of not a fair thing to assess me on, anyways. All right, so here's the conclusion. Congratulations on finishing the small agents module of this second unit. You've just mastered the fundamentals of small agents and you've built your own agent. Now that you have skills in small agents, you can now start to create agents that will solve tasks you're interested about. In the next module, you're going to learn how to build agents with Llama Index. Finally, we would love to hear what you think of the course and how we can improve it. If you have some feedback, then please fill out this form. Keep learning and stay awesome. So there we go. There you have it. I have finished uh, the unit 2.1. So 2.2 will be released tomorrow. So I'm perfectly on track. Now, what I could do is spend some more time on my cleaning agent tool. I'm pretty serious about this. I'm kind of lifelong struggled with some like basic like housekeeping sort of stuff. So I'm building this for me for sure. But I feel like this is like $1 million business idea. Like even just like a cookbook that tells you how to clean rather than how to cook, I think is a good idea, and I don't really see anything like that out there. Like who wouldn't want, like I feel like professional cleaning companies like like Task Book or something like that. I feel like these things have to like yeah, like here we go, like a professional cleaning services checklist logbook. Like I'm surprised there's nothing like this marketed towards somebody who just wants to like clean up on their own. Like a really good example is the bathtub. Like what chemicals do you use in the bathtub to get it clean? You have to use degreasers. Like who knows that? Like so like I feel like it would make a lot of sense to produce like a product like that would do really well. So, but anyways, that's it for this unit. So stay tuned for more.